Welcome back. Now we want to solve the following equation in the set of complex numbers. So we're going to say solve in C, the set of complex numbers, the following equation. I z squared plus 4i minus 3 times z plus I minus 5. So the best way is to use the discriminant. Okay, so we now in z, we know that az plus bz plus c equals 0, the discriminant. So this is a polynomial in C with these coefficients a, b, and c. We assume that a is different from 0, so to have a second degree polynomial in this set of complex numbers. So the best way, we said, is to compute delta. Delta is defined as b. It's this coefficient before the z, so it's b squared minus 4ac. Okay, so we compute this one, and once we compute that, we find its two roots. Okay, that means we try to compute this one because we take the square root of delta, so we compute this one as a square to make it easier to compute. We will see this, what we mean exactly by that when we solve. In our case, a is I, and b is 4i minus 3, and c is I minus 5. So delta is b squared, which is 4i minus 3 squared, minus 4 times I minus 5. So here we have 9 minus 16 minus 2 times 3 times 4 minus 24i minus 4i times I is 4 plus 20i. So we have 9 minus 7 plus 4, it's minus 3 minus 4i. Okay, we always try to write this one as a square because we want to take the square root of delta. So sometimes it's good to see it. Like in our case here, we can see that we can write this one as we can add and subtract 1, so we have minus 3 minus 1 plus 1 minus 2i minus 2 times 2i. Okay, so here we have this one here, which is minus 4 plus 1 minus 2 times 2i. So I'm just trying to teach you in sometimes how to get the square. So here minus 4 is 2i squared minus 2 times 2i plus 1. So here we can write this one as 2i minus 1 squared. Okay, so this is our delta. Okay, so now we solve for z. z, 1, 2 are given in function of b and the discriminant in the following manner. So b minus b plus minus square root of delta over 2a. So in this case, z1 is going to be minus b, which is here, it's minus 4i plus 3, it's minus 4i plus 3 minus square root of delta, which is 2i minus 1, so minus 2i minus 1 over 2i. So this one gives us minus 4i plus 3 minus 2i plus 1 over 2i. So we're doing some simplification, we get minus 6i's plus 4 divided by 2i. So here we get minus 3i plus 2 over I. So we multiply everything by minus I. In the bottom we get 1 minus I, it's 3 minus 2i. So we get minus 2i plus 3 for z1. Okay, for z2 it's going to be minus b, which is minus 4 plus 3i plus 2i minus 1 over 2i. So we have minus 4 minus 4i is minus minus 4i. So let's write minus 4i plus 3 plus 2i minus 1. Let's write it nicely. Over 2i. So we get minus 2i plus 2 over 2i, which is minus I plus 1 over I. We can multiply everything by minus I, so we get minus I plus 1 over 1, which is gives us 1 minus I. So we have these two roots. So let me write them here. So we found z1 is minus 2i plus 3, and z2 is 1 minus I. Let me write this one algebraic form. 3 minus 2i, 1 minus I. This is the best way, the best algebraic form. So we found the solutions for this equation, okay? So it's like the usual way. The only thing is that when we have the square root of delta, we try to write delta in some square form. We'll see what are the best way. For me to get this one into this form, I had to write it this way because I noticed this one, or maybe because I know how to write this one. So next time we're gonna see how to get from here to here quickly using the exponential form or the bracket form. Okay, the bracket form, like 1 theta is, that means e to I theta. The modulus is 1 and the argument is theta. We're gonna see how to do this one quickly. Anyways, we found the solution for this one, and I think that's it. Thank you.